Alright, now. Yes? No. Okay. Now, guys, there were 3 types of magma that you learned about with the online activity, correct? Alright, what were the 3 types?
Felsic, mafic, and
Intermediate. So, felsic, mafic, and intermediate. Now, what's important about this is that we're going to look at these 3 in more detail. In fact, there's another one we're going to put in there that's called ultramafic. Okay, so it's not just mafic, it's ultramafic. It's like the extreme of mafic rocks. So when we look at felsic, what did you guys learn about felsic? What makes felsic unique? Alright, and this is where I need feedback from you guys. You guys took notes. Tell me what you learned about felsic magma. AJ.
That it's rich in silica composition and it's usually 75% silica.
There we go. So we have extremely high silica content.
does it flow really easily?
Exactly. Right. So we basically are about 75% silica, and that actually makes sense when you look at the term felsic. Okay, the SiC, or rather the Si, represents silica. What do you think the Fe represents? Iron. So there's 2 things that felsic's really high in. Very high in silica and very high in iron content.
I have potassium and sodium.
Okay. Now, Angel, you said something else about felsic.
It doesn't flow very easily.
There we go. So we are also extremely viscous. Alright, again, that means that we don't flow very easily. So we would say it has a high viscosity. Okay, say it again. Okay, so we commonly cool underground. Why does it get stuck underground? No, not the air. Why does it tend to not be able to go to the surface?
Because it's so thick.
Exactly, because it's viscous. And the one thing that gives it that viscosity is which compound? The silica. So really when we are classifying magma, it's all based on the silica content. Right? That's actually what determines what type of magma we have. Alright, now let's talk about mafic. Well, actually, let's do this first. Felsic, what type of rocks do we get with felsic magma? Did you guys learn? Did you guys look at the crystal?
Rhyolite.
Okay, so rhyolite is an example of felsic magma. Alright, and what else? There's a big one that's for intrusive. One we've already seen. Granite. Okay. So another type of rock that is formed by felsic magma is granite. That's what I need you guys to know.
That's in the magma chamber.
Yep, and that's because that's cooling underground, right? So you get really large crystals. It's an intrusive rock. So remember yesterday we talked about granite versus basalt, that the continental crust is granitic and the oceanic crust are basaltic. This all comes down to this concept right here, that with the felsic magma being so thick, a lot of your continental volcanoes are extremely explosive. And that's because of the type of magma that's feeding into that volcano. So we look at the whole Cascade Ranges, and you go all the way up through Alaska, all of those volcanoes are extremely powerful. And those are things that tend to explode very dramatically. Let's talk about mafic. What's special about mafic? What makes it different from felsic? It has a lower silica content. So right about 50%. And definitely has a lower viscosity because of that. Okay. It can cool underground.
No, I agree.
Oh, okay.
Yeah, sorry.
But mafic actually tends to flow very easily, okay? So a great example of thinking about mafic magma would be the Hawaiian Islands, right? All the
Blows up
time,
cracks.
yeah, it basically just oozes out of the top of the volcano. Alright, so that's a perfect example of mafic magma. One thing I do want to point out to you here is the Ma
For magnesium.
is magnesium. So this is high in magnesium. Still kind of high in silica, but not as high as felsic. So this flows easily. And also somewhat dark. And the reason why it's somewhat dark is because of the lack of silica. Okay? Your silica is kind of like adding white to any color, right? It tends to be clear, so it's going to kind of drown out those dark colors. Where now, if you start pulling back on that, you get darker colored rocks. Not always, but sometimes. And so, an example of mafic is gabbro and basalt. Your basalt is going to be extrusive, gabbro is intrusive. Alright, then we have ultramafic. Okay. Ultramafic because not only are we mafic, but we are extremely mafic.
There's a lot more magnesium.
Well, in this case, we have an extremely low silica.
So almost 10 times.
Well, I'd say about 10 to 40%. But the other thing to remember is that this forms extremely deep within the crust. And therefore, you don't really get any extrusive forms of ultramafic rock. It never makes its way to the surface. So these are all intrusive rocks. Okay, I'm going to scratch that. It's not all intrusive. I don't want you to get that statement confused. Basically, all the ultramafic rocks are intrusive. So that's probably what we should write down. So all ultramafic rocks are intrusive. All right. So, you guys, on section 5.2, right there on that first page, you should have this table. Okay, do you guys have that section loaded up on your computers? Okay. Just like I told you to do. Thanks for following verbal instructions. So section 5.2, right there on the first page of the section, is this table. We're kind of filling it in together. Now, felsic and intermediate, right? You guys kind of learned about intermediate through your web quest. Basically, one of the most obvious extrusive that has a glassy texture, which means right, it has almost no visible grains. So a perfect example of that would be obsidian. What's an example of a fine grained felsic? Rhyolite. Remember, that's the nice white one, right? That's in your rock sets. Okay, what about an intermediate?
Andesite.
Andesite. Okay. Did you guys look at the picture for andesite in that web quest? Alright, you see how the crystals were set up? Alright, what about extrusive mafic? What do they have? Basalt. And that's pretty much it, right? They had basalt glass, and then they also just had plain old basalt. But what do you notice about ultramafic? There's nothing there, and that's because ultramafic forms very deep within the crust. So that is not some. Those rocks will not, or that magma never comes to the surface. So then how do we get those rocks to the surface? How do we get ultramafic rocks to the surface if it never formed at the surface?
Put layers, pushing it up.
What do you mean?
Like, When it'd be like when the lava starts to cool underground and it starts putting up layers and it starts to push it out.
Could be. Much easier way. All you gotta do is get a little bit of crumpling going on in the crust, and then you take those bottom layers and shove them to the top, right? So you get plate tectonics. Is actually how we get some of our very deep layers that get pushed to the top. Which is kind of what's up. Plate tectonics covers volcanism. All right, what about intrusive felsic? What's an example of intrusive felsic? Granite, right? That's kind of the big one. That's what I really want you guys to. Oh, that's what I want you guys to know for sure, right? Granite, obsidian, and rhyolite are the two big ones I want you guys to know there. And then what's the other one there? Very important. Pegmatites. Okay. What about intermediate? Diorite. Is that coarse grain or very coarse grain? Coarse. Diorite. And what else? We don't have any very coarse on that one? Okay, what about mafic? Gabbro is coarse grain. Okay, what else? Nothing else? Now, what about ultramafic? Peridotite. You guys remember that's the green mineral I showed you guys before? And this is where we get peridot, which is made out of olivine. Again, where do we find olivine? What layer? The asthenosphere. Yeah, between the mantle and the asthenosphere. That's how deep ultramafic magma really is. It is just barely getting out of the mantle and coming into the crust. Okay, so it's a very, very, very deep magma chamber. All right, and what else for a very coarse grain? Dunite? So D-U-N? Right.
Just for coarse grain.
Oh, just for coarse grain? Okay. So guys, that's just a table I want you to keep in mind when we start looking at these rocks or ask yourself, okay, what type of rocks are they? So we'll go ahead and we'll